when you can't integrate by taking the antiderivative, or in other words, using the power rule for derivatives in reverse, like we've been doing for previous problems, then you can use something called the substitution method for integrals. Now, the substitution method, and we'll use u to represent our substitution. How you know what to let u equal to, if you have something under a radical or some binomial or trinomial or polynomial raised to an exponent, or if you have e raised to some power besides x, then those items are what you usually let u equal to. So for this example, we'll let u equal to x squared minus 7. Now the next step is take the derivative of both sides. The derivative of u is just du. The derivative of x squared is 2x. And the derivative of negative 7 is 0. We need to put a dx here. Now you may, in some problems, have to divide to get your particular substitution just exactly right. But look at your original problem. We have a 2x dx, and we have a 2x dx here. So we don't have to divide by anything. We can just plug in our u and du. So du is 2x dx, and u is the x squared minus 7. Now we can rewrite the square root of u as u to the 1/2 power. And now we can integrate this fairly easily by undoing the power rule. So we will add 1 to the original exponent, and that's what we divide the term by, that 1/2 plus 2, 1/2 plus 1. So this will give us u to the 3/2 power all over 3/2 plus c. Now, when we divide by 3/2, we'll flip it and use the reciprocal. So that's actually 2/3 u to the 3/2 power plus c. Now, because our original problem was in terms of x, our final answer needs to be in terms of x also. So whatever u originally was, plug that back in. So our final answer is 2/3 times x squared minus 7 to the 3/2 power plus c. Let's look at another example involving the substitution rule. We have the following problem. The integral of 4x times, in parentheses, x squared plus 5, and all of that is cubed, dx. To cube the x squared plus 5 would take a while, so let's use u substitution. Let u equal to the x squared plus 5. Oh, one thing I forgot to mention, if you are given a constant, then you can pull that constant in front of the integral sign. So we'll go ahead and do that and bring down the rest of the problem. U equal to x squared plus 5. take the derivative of both sides. So the derivative of u is du, and the derivative of x squared plus 5 is 2x dx. Now, before we plug everything into our original problem, we have an x dx, but we have a 2 right here. To get rid of that 2, just divide both sides of your derivative by 2. So this is actually x dx equal to 1/2 du. So what that means is when we plug in our u and du respectively, we can pull out that 1/2 and bring it out with the 4. So x dx is du. X squared plus 5 is our u, but it's being cubed. Outside, 4 times 1/2 is 2. And we can find the antiderivative by adding 1 to the original exponent. So that would be u to the 4th power over 4 plus c. Now, before we plug back in what u originally was, simplify the 2 and the 4. Now, in place of the u, plug back in x squared plus 5, and don't forget your 4, all over 2 plus c. Next, let's look at an integral involving the base e. There's a special rule, sorry for the delay, there's a special rule that says the integral of e to the u du, is equal to e to the u plus c. So keep that in mind. It'll help us integrate the next problem. We have x cubed times e to the x to the 4th power dx. We can't take the antiderivative by undoing the power rule, so we have to use u substitution. Let u equal to x to the 4th power. So taking the derivative of both sides, we have du equal to 4x cubed dx. Now, if you notice over here, we just have a plain old x cubed dx. Does not have a 4 attached to it. So to get rid of that 4, just divide both sides of your derivative by 4. So we now have 1/4 du equal to x cubed dx. Now we can plug in our u and du respectively. X to the 4th power is our u right here. So we have e to the u. X cubed dx is our du. And we pull the 1/4 outside the integral. So the integral of e to the u du is still e to the u. So we have 1/4 e to the u plus c. And our final answer, once we back substitute what u originally was, is 1/4 e to the x to the 4th power plus c. Next, let's look at an integral problem involving a trig identity. We need to find the integral of tangent x dx Well, we don't know the integral of tangent x, but we do know that tangent is the same thing as sine over cosine. Now let's use substitution to integrate. I'm letting u equal to cosine x. If you pick the wrong thing to represent u, then that's not a problem. Just go back and pick the other part. Taking the derivative of both sides, du is equal to negative sine x dx. Well, we have sine x dx in the original problem, but we don't have a -1, so we have to get rid of it. Just divide both sides by -1 in your derivative. So negative du is equal to sine x dx. So that negative sign we can bring out, and sine x dx is du, and cosine x is u. Well, technically, that's the same thing as 1 over u du, and the integral of 1 over u du is natural log absolute value of u. The last step, replace what u originally was. So our final answer is negative natural log absolute value of cosine x plus c.